We started our slides yesterday, but since they were so long and so many of them, I decided to split it into 2 days. So today we are continuing slides. The whole section is 69 to 112. Today we'll be doing 94 to 112. And then you should be prepared for an assignment tomorrow that we'll post at 8 o'clock in the morning. We're talking about ions and ionic bonds. Ions are formed when electrons are gained or lost. When you lose, or when an element loses or gains an electron, it forms an ionic bond. The electric force is very powerful. A small imbalance in charge results in a very powerful attraction. An ionic bond forms when there are 3 ways. 2, 3. A group 1 atom loses an electron and becomes a positive ion. At the same time, a group 17 gains an electron and becomes a negative ion. The 2 ions are strongly attracted and snap together, releasing a lot of energy. The released energy equals the energy of the ionic bond. Ionic bonding. This shows the progression of ions being created and an ionic bond being formed. Note the size change and the use of the positive or negative subscripts to indicate a positive or a negative ion. Fluorine takes an electron from lithium, creating a positive lithium ion and a negative fluorine ion. Note the changes in size. Okay? That's what happens. A positive lithium ion and a negative fluorine ion have opposite charges indicated by the subscripts of a plus or a negative. They attract and become stuck together by a powerful electric force, because if you remember, opposites attract each other. NaCl, this is common table salt. This is a balanced chemical reaction for the formation of an ionic bond between sodium and chlorine. Note that since chlorine gas is diatomic, so 2 ions, you need 2 sodium atoms, and we form 2 NaCl particles. So technically it's 2 Na plus Cl2 gives us 2 NaCl. Remember, if it's the big number, and even though that's not written, it does have a small number 1 subscript. So that would be 2 times 1 is 2, and then you have 2 Cl. So if you have the big number in front here, that goes for everything. There are no plus signs. So that becomes 2 sodium and 2 chlorine. This is a video of the explosive formation of ionic bonds. Let me switch and we'll play that. And let me have to put it in a bar by itself. Let's try that. Oh, maybe here we go. There it is.
This reaction can be safely demonstrated in school. In this case, chlorine has been placed in a flask, and some sand is used to protect the glass from the heat produced in the reaction. A long syringe needle has been used to pick up a small piece of sodium, and using the glass tube, it is dropped into the sand. The syringe is then used to deliver a few drops of water, which causes the sodium to ignite and then react with the chlorine. The product is sodium chloride, which appears white only when excess chlorine has been removed from the flask.
Okay. Close this out. Okay, and here we're back. And this is the result of that reaction, the generation of sodium chloride, also known as table salt. Ionic bonds do not form, this is important, do not form molecules. That is only done by covalent bonds where the electrons are shared. Ionic bonds create a material with a specific ratio of ions, but not a fixed number of ions. For instance, NaCl consists of one sodium ion for each chlorine ion, but that could be 1 each or 10,000 each. Only the ratio matters, not the numbers. With molecules, the numbers are fixed. For instance, water, which is formed by covalent bonds, has 2 hydrogen atoms and 1 oxygen atom. A single water molecule cannot be 4 hydrogen and 2 oxygen atoms. NaCl. On the left is an image of NaCl, a salt crystal. If you were to find salt naturally, this is what it would look like. On the right is a representation of the crystals with the chlorine ions shown as green and the sodium ions as purple. This is an extended structure in that it can include any number of ions as long as there is 1 Na for each Cl. Formula unit. Contrast the representation of a water molecule with that of a salt crystal, not to relative size, of course, it's just so you can see. The water molecule has exactly 2 hydrogen and 1 oxygen. This is a water molecule right here. It's kind of hard to write, but I think you can see it with my marker. The water molecule has exactly 2 hydrogen atoms and 1 oxygen atom. An ionic solid has a ratio of ions. In this case, you just have to have 1, if you just have 1 and 1, that's fine. If you have 2 and 2, that's fine. 3 and 3, 4 and 4, that doesn't matter as long as it's a 1-to-1. But there can be any number of them forming large extended structures as long as the ratio is always 1-to-1. NaCl isn't a molecule, it's a formula unit, which means it is the ratio of the atoms in lowest terms. Just like we call atoms, just like we can call atoms and ions both particles. Particles. The reason that we have used and will continue to use the term particles in this course is that it describes a range of entities. It can be atoms, ions, molecules, or formula units. So we can know that all of those are included when we refer to particles, even as the types of a particle may vary from case to case. These are all examples of particles. Okay, we probably are getting close. Oh, no, it is on 101, so we're going to 112. An ionic bond is formed by the blank of an electron between 2 atoms, forming 2 oppositely charged ions that are attracted to one another. Share, transferring, creation, or destruction. Let me get back on my arrow there. And it would be B, the transferring. A covalent bond is formed by the blank of electrons, forming bonds that allow each atom to have a stable number of electrons. Sharing, transferring, creation, or destruction. And that one is sharing. Which of the following are formed by covalent bonds? H2, F2, N2, or all of the above? And it is D. All of these are sharing electrons. When Na combines with Cl, Na loses an electron and Cl gains one. Na gains and Cl loses. Both gain, both lose, and in this case it is A. Na loses, Cl gains an electron. Ionic bonds are formed between elements at opposite sides of the periodic table, elements that can share electrons to become more stable, water molecules, 2 negatively charged ions. This one obviously, of course, has to be A. Metallic bonds. We've talked about covalent bonds, which form molecules when a fixed number of the specific atoms, and ionic bonds, which form extended structures with fixed ratios of different types of atoms. Lastly, we will briefly talk about metallic bonds, which form, let me get back on my marker, which form between large numbers of metal atoms. Metallic solids are formed when a number of metal atoms share electrons with each other, so they become more stable. The electrons are not shared between specific atoms, because that would be a covalent bond. And electrons are not taken from one, because that would be ionic. In metallic, they are shared between large numbers of atoms, creating a sea of electrons that move freely between the atoms. So basically it's like they're all pooled in there together, and whichever one needs it, uses it at that time. Metallic bonds form extended structures with unlimited numbers of atoms. A large number of electrons, which are free to move between atoms in metal, result in metals being good conductors, conducting heat and electricity. A bar of metal held together by metallic bonds can be very strong, but it can also be malleable, meaning that you could hammer it into thin sheets. Like if you think of a metal roof on a barn, or some of you may have metal roofs on your houses. That's how that metal can be hammered. It's malleable, so we can spread it out into a thin sheet, and the electrons are constantly moving around, and that allows it to be spread out into a sheet. To the left is a microscopic image of gold atoms connected by metallic bonds. So you just kind of imagine they're all just kind of vibrating and moving around in there together. The electrons are too small to see, of course, but this is just to give you an idea of what it might be like. To the right is a gold bar formed by metallic bonds. So this is what it would look like as we could see it. Bonds formed by large, let me get back on my arrow. Bonds formed by a large number of atoms sharing electrons with one another to form a